So if we have our unique algorithm, and it's in the worst case, so I'm going to just mark that for some problem, so we actually know what's going on. And again, I don't know why my mouse pointer occurred. We can just simplify this name and then try to form a summation for this. Okay, so we have two for loops. Okay, so instantly we're going to have two summations. Okay, we've already worked out the basic operation. When we're doing this, it's just going to have a cost 1. So we can write that in instantly. But now we're going to have ourselves the outer for loop. I can't remember if it was an inner while loop. That would actually be a good thing to, that's 2 for loops. I actually managed to forget that in that amount of time. That was impressive. It's going to be here. Whoops. That's kind of confusing why that has got so big, but there we go. And then we will have an inner for loop. Okay, which will be this summation. Okay, and then we have our basic operation. Okay, which is the 1. Okay, then we just take a look at from 0 to the length -2. Okay, so we can then for the outer for loop, we can say this is going to be equal to 0 up to n-2. And for our inner for loop, it goes up from i+1 to n-1. Okay, so we give it a different index, and it goes from i+1 to n-1. Okay, now for a lovely simplification. I'll maybe take myself a bit of space over here. Okay, we're going to begin with the simplifying this part first of all, because we already have a summation of 1, so we know we can actually simplify that quite quickly. So I'll just put the outer for loop here first of all and say that we can simplify this. It's going to be the upper limit minus the lower limit plus 1. So that is going to be n-1 minus I +1 plus 1. Hopefully I got that right. Okay. So now we've got things in terms of just a single summation, but we have n in here, and we'd ideally like that not to be there. Okay. We can actually write this simpler as just n-1 minus I. Okay. So then we can multiply this through and take out a factor. So I'm going to take out n-1 from this product, which will leave me, why have I done that? That's a really bad idea. This should be 1 there. So I can put things in terms of I and a summation in terms of 1. Okay, so if I multiply that through, this will be the same, I equals 0, and that will be of 1 minus, I really should have done that the other way around, but there we go. It doesn't actually matter, but it'll look confusing later on. -2 of I. Okay. Once again, we can simplify. So we can simplify with a bit different color here. So we're going to end up with n-1. And it's the upper is n-2 minus lower plus 1. We've got simplification minus, I really should have done like a copy and paste of this because it takes a long time to draw out. Okay. Then we can just multiply these out, or we can simplify this. And that's n-1 upon n-1. And here again, we have a simplification we can make. So if I go back to my summation sheet, which I've now lost, okay, we're going to use the simplification here, put this in closed form. So if we have the summation of I, we can write it as n upon n plus 1 over 2. Okay, which I can do here. But I have to remember that n is in n minus 2, so it's going to be n, whoops, wrong color, n minus 2 upon n minus 1, so it's n minus 2 replacing that n minus 1 all over 2. Hoping that actually worked. At some point I will have probably made a mistake, but that's okay. Okay, we start to multiply all these things out. So n upon n squared, so that's going to be n squared minus 2n plus 1. And we multiply all of this out, we're going to get something like n squared minus 3n plus 2. Okay. And again, now we're just gathering everything together. We're going to get something along the lines of 2n squared minus n minus 2 over 2. Okay. So we can do that one further. We can just say that is n squared minus n over 2 minus 1. Okay, at this point in time, we've simplified everything down just by using a little bit of summation, simplifications, and we can find the most dominant term. So that means we can throw away some of the other terms as well. Okay, and then we can make the conclusion that, well, our algorithm, I've forgotten what it's called now, unique. It is a member of the quadratic class. So now we say theta n squared. Okay, as you can see, that went on for quite a while, and I'm already wondering how the hell I'll split that when I actually try to make a video of that.